There is a place in the cosmos where the lights simply stop. It's called the Boötes void, a region of space with such low cosmic mean density that it feels like a glitch in the architecture of the universe. Think of it as a galactic desert, a hollow, crushing, absolute blackness that defies the very idea of a cosmic neighborhood. While most of the cosmos is structured like a sponge or a luminous web, this area is the universe's desert, a place where the common laws of distribution are simply absent. We're going to journey into the most terrifyingly empty place in existence to understand why it exists and what it tells us about the end of everything. Now, let's say you're floating in the center of the constellation Boötes, the herdsman. You look in every direction, but there are no stars, no shimmering clusters, just an absolute suffocating blackness that stretches forever. To get here from Earth, you'd have to travel 700 million light years. Even with our current technology, the trip would be a nightmare of scale, taking 13 trillion years just to reach the edge. Once you're inside, the isolation is total. If you tried to fly across this emptiness, it would take another 6 trillion years to cross it. It's a claustrophobia born of infinite space, a place where the lights of the universe simply vanish. But here's the strange part. While it looks like a graveyard of nothingness, some believe this silence is actually a mask for something far more advanced. Back in 1981, a group of astronomers led by Robert Kirshner, working across the University of Michigan and the Harvard-Smithsonian Institute for Astrophysics, stumbled upon something that didn't make sense. They weren't looking for a hole in the universe, they were simply mapping it. They used redshift surveys, a method that measures the distribution of interstellar objects by calculating their redshifts. For those of us not in the lab, a redshift happens when light from a distant object is stretched to longer wavelengths as that object moves away from the observer. It's essentially a cosmic speed trap that tells us how far away things are. But as Kirshner and his team plotted their data, they noticed a terrifying gap. Where the maps should have been crowded with galaxies, there was just a blank spot. It wasn't a technical glitch or a smudge on a lens. The data was screaming that there was a massive region of space where almost nothing existed. They had just found the Boötes void, and the sheer scale of that absence was a shock to everyone involved. Let's talk numbers, because the scale of this nothingness is where the real shock sets in. The Boötes void stretches 330 million light-years across. To give you a sense of that volume, the number of Earths required to fill the Boötes void is 1.47 times 10 to the 51st power. That is a number so large it ceases to be a quantity and becomes a physical weight. But it's the emptiness that is truly haunting. A typical region of space the size of the Boötes void would normally contain over 2,000 galaxies. Instead, the Boötes void contains only 60 galaxies. Think about that gap. In this wasteland, you'd encounter a galaxy every 5.5 million light-years on average. Astronomer Greg Aldering stated that if the Milky Way were in the center of the Boötes void, humans would not have known other galaxies existed until the 1960s. If we had looked up at a sky of absolute ink, we would have believed we were the only island of light in a dead universe. Even at this staggering size, it only takes up approximately 2% of the diameter of the observable universe. Yet it feels like a hole ripped into the fabric of reality. This void isn't just a gap, it's a preview of the ultimate isolation waiting for the cosmos. To understand how a hole this large actually forms, we have to go back to the very beginning. It all started with quantum fluctuations during the early universe, which caused some areas to be slightly more dense than others. This tiny difference in density was the seed. Over billions of years, gravity acted like a cosmic vacuum, pulling matter from less dense regions into denser regions. This process is what created these massive voids. This is part of a larger architecture called the cosmic web. This web consists of filaments, where the galaxies actually live, and voids, the empty spaces between them. It's a system of opposites. Galaxy clusters within filaments emit more energy than colder, empty voids, allowing them to be mapped via thermal imaging. Joseph Clampett, a researcher at the University of Pennsylvania, describes this structure in a way that makes it easy to picture. He compared voids to shallow troughs in dark matter distribution, while galaxies are like towering peaks. The Boötes void is simply one of those troughs, a place where the matter was drained away, leaving behind a staggering, cold silence. It's a strange irony that we define this abyss by what it is not. We're essentially mapping a negative photograph of the universe. When we look at the same region, we see the walls of the cosmic web, specifically the Boötes superclusters that border it. It makes you realize how lucky we are to live in a crowded neighborhood. For instance, the Milky Way is part of the Virgo cluster, which belongs to the Laniakea supercluster. We're surrounded by neighbors, while the void is just a hollow trough. But we aren't entirely alone in the structure. There's a void near the Milky Way called the local void, a smaller, darker pocket of nothingness that reminds us that these empty spaces are the structural bones of the cosmos. Now we move into the territory of the unexplained. When you look at a map of the Boötes void, the sheer emptiness is so unnatural that some people refuse to accept it as a natural phenomenon. They look at the void and see a perfect cosmic scale vacuum cleaner. One of the most intriguing theories involves a concept from 1960 when physicist Freeman Dyson proposed the idea of Dyson spheres. These are theoretical megastructures that an advanced civilization could build to completely surround their stars, to capture every single drop of energy. If a hyper-advanced species had decided to settle in this region of space, they could have expanded across the entire void, building Dyson spheres around every star and thousands of galaxies. Think about it. If they had successfully engulfed their stars in these shells, the light would be trapped inside. From our perspective on Earth, those stars and galaxies would simply vanish from the sky. The Boötes void wouldn't be a hole in the universe, but a hidden city of a trillion stars, effectively cloaked by the very technology that powers them. But does the science actually hold up? Well, if we look at the numbers, those fringe theories crumble. Take the black hole theory. It's a fascinating idea, but it's simply impossible given the scale. The largest known black hole, TON 618, is only 0.2 light-years across its event horizon. Comparing that to the 330 million light-years of the void, it's like comparing a grain of sand to an entire continent. And what about the clouds of gas and dust that could be hiding the galaxies? The dark nebula theory is equally unlikely. The largest known dark nebula, the Xoc nebula, is only 30 light-years across. In the vastness of the Boötes void, a nebula that size is practically invisible. If a nebula were to fill this entire region, we would see an effect on the surrounding cosmic web, which we don't. Does it make sense for a law of physics to break down on such a massive scale just to hide 1,000 galaxies? The evidence points to a real physical emptiness that is simply too large for any single object to explain. Looking at the Boötes void, some scientists theorize that it is actually a window into the future of the universe. It's not just an empty space, but a physical representation of a state of near total emptiness that the universe may reach if it expands indefinitely. If we look at the rest of the cosmos, we're surrounded by the luminous filaments of the cosmic web. But here, the expansion is winning. It's a terrifyingly quiet preview of a time when galaxies drift apart until the light of other stars disappears from the sky. You're looking at the end of the universe, just shifted in space rather than time. This is the existential dread of the expanding void, and it is grounded in the real, cold physics of cosmic expansion. Robert Kirshner's discovery changed how we see the architecture of space. For a long time, the Boötes void felt like an anomaly, but it turns out it was just the beginning of a much larger pattern. We now know that voids make up 80% of the observable universe. They aren't the exception, they are the rule. Even more shocking is that the Boötes void has been eclipsed in size. The KBC void is currently the largest known void, spanning 2 billion light-years across. The Eridani supervoid and the SLO Great Wall Void, which are both over 1 billion light-years in size. To find these giants, projects like the Dark Energy Survey have mapped a quarter of the southern sky and examined around 300 million galaxies. We're finally seeing the true hollow skeleton of the cosmos. Think about those few lonely islands of light still clinging to the emptiness. Astronomers call these isolated survivors field galaxies because they exist completely cut off from the warmth and gravity of massive clusters. It makes you realize how extraordinary our own position is. We live in a crowded neighborhood, surrounded by the comforting glow of millions of neighbors. But the field galaxies in the Boötes void are the ultimate outliers, drifting in a silence so absolute it defies comprehension. But how does a galaxy survive in such total isolation? And what does that solitude reveal about the nature of the space we call home? The Boötes void is more than just a hole in the sky. It's a structural necessity of the cosmic web. Through the work of Robert Kirshner in 1981, we discovered a region 330 million light-years across, where only 60 galaxies exist, where 2,000 should be. This staggering absence of matter is not a glitch, but a result of the primordial quantum fluctuations and gravity's relentless pull. It's a window into a far future, where the universe continues to expand, drifting galaxies apart until the light of other stars vanishes from our view. We're left with a concrete, cold reality. The void is not just an empty space, but a preview of the same isolation that eventually awaits the entire cosmos. What remains when the last light in the void goes out?